everyone. In this video, we will work on number 33 in section 8.3. We are given a function cosine x. And we know we can write down the Maclaurin series, right, of this term. Now, we would like to show whether the function itself, cosine x, equal to its Maclaurin series. We could analyze this one by considering the Lagrange form or the remainder terms, okay? The remainder terms are an x. There are two ways to write it: integral form, another one is the derivative form. Lagrange is actually the derivative form, which I will show here. Right? Notice that there's an unknown constant c, which is supposed to be between 0 and x. However, here we don't actually need to know what exactly the value c is, okay? Now, the function f is cosine, taking derivative, it could be negative sine, negative cosine, right? But no matter what, the derivative function are always the type of a sine and a cosine, okay? So we don't have to break it into cases to discuss, what is the value of n, right? We don't have to do that, right? All right, we just do symbolically, right? Cosine x, taking n plus 1 derivative, evaluate at the point c, right? Just plug in. Now, what we really want to do is to show this remainder term will converge to 0 for all the x. That means we choose any x value in the real number line and then fix it. All right. Now the x appeared in the remainder term is just a constant. All right. Now we want to take the limit. Now we can establish the lower and upper bound for this term. Take the absolute value of Rx. Obviously, we have a lower bound 0. For the upper bound, it is important to estimate the absolute value of this n plus 1 derivative of cosine. As we discussed before, it's always the type of cosine and a cosine. So we could have an upper bound 1. All right. So the terms left on right hand side will be this one. Take the limit. We also know the factorial function will dominate the numerator in this particular case. All right. So now we could just apply the squeeze theorem, right? Lower bound, upper bound both converge to 0. Then the middle term, which is the remaining term, will also converge to 0. Right? So this is basically how we can solve this particular question. All right. The key is to write down the general format of a remainder term, of course, the Lagrange form, right? And then utilize the special structure of the higher order derivative of function of f, right? We could bound this n plus 1 order derivative. Okay, and then evaluate the limit that will solve, that will prove this, okay? So as a byproduct, this question tells us that cosine x function equal to its Maclaurin series. And this is true for any x. Okay, thanks.